Now let us see example number 2, which is an application of Lamis theorem. So a particle is placed at the center O of the circle, which is inscribed in a triangle ABC. Forces P, Q are acting along OA, OB, OC respectively are in equilibrium. Then prove that P upon cos A by 2 is equal to Q upon cos B by 2 equal to R upon cos C by 2. So let us start its solution. For the purpose of to get the solution, according to the given data in example, we have to construct a figure that will elaborate how we can solve the problem. So let us draw the figure. This is a triangle ABC and one circle inscribed in this triangle whose center is O. Join the points OA, OB, OC, and along the OA the force is P bar. So this is along, P bar is along this direction, Q bar is along this direction, and R bar is along this direction. But the interesting thing is, from the figure, the circle is inscribed in triangle, inscribed in a triangle. Therefore, this circle is called as incircle. And we know that when the circle is incircle, then its center O is called as incenter. And according to the geometry, we know that when O is the incenter of triangle ABC, that means OA, OB, and OC are angle bisectors of A, B, and C respectively. Because we know that three angle bisectors of a triangle are concurrent, and therefore they must meet at one point, and that point, which is a common to all the three angle bisectors, is called as an incenter. So since it is an incenter, we can say that OA, OB, and OC are angle bisectors. Therefore, this angle is, because of this is angle bisector, this is A by 2, this is B by 2, and this is angle C by 2. Okay. Now we can write this measurement of an angle OAB is equal to measurement of an angle OBA, that is equal to A by 2. Similarly, measurement of an angle OAC is equal to measurement of an angle OCA is equal to C by 2. The measurement of angle OBC is nothing but equal to measurement of an angle OCB, and this is equal to B by 2. So these are the three forces, and we need these angles to apply the Lamis theorem. So in a triangle, OBC. The angle B is here B by 2, it is C by 2, and we know that the sum of three angles of a triangle is 180 degree. Therefore, in a triangle OBC, the measurement of an angle BOC plus this angle B by 2 plus C by 2 is equal to 180 degree, that is what? Pi. And therefore measurement of an angle BOC is equal to pi minus B by 2 plus C by 2 by transferring these two angles to right hand side, right? Similarly, we can calculate suppose measurement of an angle BOA, that is equal to pi minus A by 2 plus B by 2. I am considering this angle. That means I am considering the triangle BOA. Similarly, the measurement of an angle AOC, that is equal to pi minus A by 2 plus C by 2. So these are the three angles we need to use Lamis theorem, because already we know the three forces, and these are the three angles, this one and this one. So now I can use Lamis theorem. So in the Lamis theorem, if I am considering, suppose this is a P, so P divided by sine of angle between this and this angle is nothing but pi minus B by 2 plus C by 2. So by Lamis theorem, we can write P upon sine of angle between Q and R is equal to Q upon sine of angle between P and R is equal to R divided by sine of angle between P and Q. So therefore P divided by sine of that angle is nothing but pi minus B by 2 plus C by 2 is equal to Q upon sine of the angle between P and Q is nothing but pi minus A by 2 plus C by 2 is equal to R upon sine of angle between P and Q, that is nothing but pi minus A by 2 plus B by 2. Now just we will solve this simplify these three ratios. Now this is a multiple of pi. So when it will multiple of pi by 2, then it is called as a lambda, and lambda will change sine into cos. But this is not a lambda because it is not a multiple of pi by 2. So it is a multiple of pi. And therefore it is in our language we can treat this as a subgen family, and therefore it will not change sine into cos. It keeps sine as it is. Therefore we write this as a P divided by sine of the second angle is B by 2 plus C by 2 is equal to Q upon, again this is a subgen family, so this is a sine of A by 2 plus C by 2 is equal to R upon sine of, this is a multiple of pi, therefore we are keeping sine as it is, and this is A by 2 plus B by 2. Now we have to simplify these ratios in the denominator. We know that ABC is a triangle, therefore we know that A plus B plus C is equal to 180 degree, that is pi. We need the B by 2, C by 2, therefore dividing both sides by 2, we are getting A by 2 plus B by 2 plus C by 2 is equal to pi by 2. And therefore here B by 2 plus C by 2 can be written as pi by 2 minus A by 2. So therefore this ratio can become as P upon sine of pi by 2 minus A by 2 is equal to Q upon sine of pi by 2 minus B by 2 is equal to R upon sine of pi by 2 minus C by 2. Now this is a compound angle whose first angle is odd multiple of pi by 2, therefore it is a lambda, therefore it will convert sine into cos. This is in the first quadrant, therefore no issue of plus minus sign. So therefore these three ratios will become as P upon, due to this odd multiple of pi by 2, sine can be converted into cos. The angle, second angle is keeping as it is A by 2 is equal to Q upon, again this pi by 2 convert sine into cos, and the second angle is B by 2 keeping as it is equal to, last one is R upon cos of second angle is C by 2. And this is our required result that we want to show that.